This video is going to give you an overview of what projectile motion is and what you should expect. The formulas and the concept behind projectiles is based on the fact that it is two-in-one motion. What do I mean by this? Remember when we did motion, we started by saying, okay, we have horizontal linear motion, a motion that's not affected by gravity. For example, a car driving on a road, just moving horizontally, it has an acceleration of its own. And then we went on to motion under gravity. That's a vertical motion, but this motion is actually affected by gravity. Now we are in projectiles. Projectiles is a combination of those two motions, the horizontal and the vertical. So a projectile motion always has two components, the vertical component and then the horizontal component. Let's just call it Y and X. Alright, a typical projectile is an object which is launched and allowed to fly off under the influence of gravity only. So it does not have its own constant acceleration, right? A plane taking off from an airport is not a projectile. Even though it will start to move and then fly off, it's not a projectile because it has its own constant drag. An example of a projectile is a ball which is tossed. For example, a basketball which is tossed onto the hoop, the net, or whatever. So it follows a parabolic path. Let's say this is where the net is. It follows a parabolic path when it is launched. The reason for this parabolic path is because it has two components of motion, the vertical and the horizontal component. I'll continue to say this. The vertical component is due to the fact that gravity is always acting downwards, while the horizontal component is due to the initial launch or the initial velocity, which is u. So this ball was launched with an initial velocity u, right, and allowed to fall or fly off under the influence of gravity. So the reason why this body comes down is due to gravity and gravity alone. That is what defines a projectile. That being said, let's go back to our diagram of the vertical and the horizontal axis, and let's see some components or parts that has to do with a projectile, terms and parts that has to do with projectile motion. So I'm going to draw a parabolic path here to show the motion of an object which was launched from an angle theta inclined to the horizontal. Now at every point in the motion of this object, it's going to have two components of velocity. Since it was launched at an angle, it's going to have a vertical component of that initial velocity, and it's also going to have a horizontal component. You represent that as uy and ux respectively. So down the center is u, which was the initial velocity that this object was launched with. From resolution of forces, remember I taught you guys how to resolve to horizontal and vertical. Now if we apply that here, it just means that for the vertical component is going to be equals to u, that is the initial velocity which was launched with, sine the angle theta, and then the horizontal component rather is going to be equals to u cos theta. All right, now this object is going to move along this path until it reaches a maximum or peak height. I'm going to just label this h. Now this maximum height, this point of maximum height, the velocity here is just horizontal. Now only the horizontal component actually acts here. So we just have ux acting because it ceases to go further up. And then along the motion, we now have a change in direction of velocity. So now we still have the same horizontal velocity acting, and then the vertical component becomes negative. Why does the vertical component of the velocity become negative? It's because it's different from the direction which it was going. So remember, it was going upwards before, the vertical component, but now the vertical component is coming downwards, and this is due to what? Acceleration due to gravity. The constant push of acceleration to gravity on this object makes it follow this parabolic path. Now you may notice something, that along every single point in its line of motion, the horizontal part of the velocity remains constant. Like, the horizontal part remains constant. It does not change due to gravity, right? It's not affected by gravity. So the horizontal component of a projectile motion has nothing to do with gravity, just the vertical component. Do we understand that? So formulas which we are likely to see in projectile motion include, let's just start with the time of flight, also called total time of flight. Now, time of flight, represented by t, is the total time taken for a projectile to move from where it was launched to back to the ground level. So it's the total time taken for a projectile to complete its motion that we call time of flight, and is given by the formula 2u sine theta all over g. This is the formula for time of flight, or total time of flight. Now you may be asked, what about the time to reach maximum height? As you can see in this projectile motion, this diagram, it's divided into two components actually. A point where the object reaches its maximum height, and the point where it starts falling down. So those are the two halves. If we divide the total time taken for the projectile to move from this point A to point B, then from point A to point C, rather, let's just say point A, point B, and point C. So the total time taken to move from point A to point C divided by 2 is going to give us the total time taken for the projectile to move from point A to point B. Hence, time taken to reach maximum height max height is going to be given by the formula t is equals to over 2, which is, if you divide this by 2 cancels out, and we're left with what? U sine theta over g. Please take note of this. There is a big difference between time of flight and time to reach maximum height. Now the next parameter or the next term in projectile we're going to be looking at is the height or maximum height. Represented by h. Now the maximum height in a projectile motion is given by the formula h is equals to u squared sine squared theta all over 2g. For convenience, psi square theta is the same thing as sine theta in brackets then squared. So don't get confused when we say sine squared theta. This is just what it means. So the third term we're going to be looking at is the range. These are things you can be asked to calculate for in projectile motion, and the formula for range is given by rho is equals to u square sine 2 theta all over g. All right, one more formula, maximum range. Now, an object can only reach its maximum horizontal distance if it is launched at an angle of 45 degrees. Please take notes. And it's actually proven. If you launch an object at an angle of 45 degrees, then we substitute into the formula, you arrive at something like this: sine 2 times 45 degrees. This is equivalent to sine 90 degrees, which is equals to 1. So 1 times u square over g will actually be the maximum possible range you can attain. And why is this? Every other value of sine theta is less than 1, and we always decrease the value of u square over g. So this is the formula for maximum range. All right, let's take another term in projectile. Why are we missing out? Okay, I don't think I'm missing out anything. All right, the velocity which an object is launched with during a projectile has two components, and that can be related by this formula. The vertical and the horizontal components. This is from Pythagoras theorem. So the resultant is given by ux squared, square root of the sum of ux squared plus uy squared. Similarly, the final velocity will still be v is equals to vx squared plus vy squared. I don't know where you might need this formula, but just take note of this. Alright, so that's all for the conventional case where a projectile is launched from the ground or at an angle of theta to the horizontal components. You may be tricked in an exam and you may see that you realize that the object is launched at an angle inclined to the vertical instead of the horizontal. Now, in such cases, all you have to do is to change from sine to cos in these your formulas, because if you use these formulas the way they are and you were clearly told that the object was launched at an angle inclined to the vertical and not the horizontal, you're going to fail the question. Another thing to do is that, okay, you can subtract from 90 degrees because if this is, we have an angle here theta, it means this other angle is going to be 90 minus theta, right? So we can always get the angle inclined to the horizontal. So if you are given an angle inclined to the vertical, you can just subtract from 90 degrees and then you get that angle inclined to the horizontal, then use your formula normally. Or you can just decide to use cos instead of sine. It's your choice to make. Another case of projectile is when the object is launched from a height. For example, a cliff or a tower or a mountain, whatever. So an object can be launched horizontally and then allowed to fall to the ground level. What kind of curve is that? Okay. So this is the initial velocity with which the object was launched with, and then it reaches ground level. So let me draw the ground level. Most times in questions like this, you are usually asked to calculate the height of the tower which it was launched from, or you are asked to calculate the range of motion. That's the maximum horizontal distance which the object reached. For this is a separate case from projectile motion, the typical projectile motion where you have an inclined angle and the formulas are different. So whenever you are given a case like this, just use the three equations of motion under gravity, which are V is equals to U plus gt. We have H is equals to ut plus 1 over 2 gt squared, and then we have v squared is equals to u squared plus 2gh. These formulas, you apply them when you're asked to calculate for anything related to the vertical component, as only gravity acts or affects the vertical component. But when you're asked to calculate anything concerning the horizontal component, for example the range, you use your simple formula r is equals to vt. That's just it. So distance is equals to velocity times time. That's just the formula you use. And sometimes you can use it in conjunction with the formulas, the three equations of motion. Now, one thing to note, please. If you are asked to calculate the height of the tower or the height of the cliff or the height from which it was launched from, and the object was launched horizontally with a velocity of, let's say, 30 meters per second, you are not using that initial velocity in any of these equations. Rather, the vertical component of the velocity is going to be 0. Since the object was launched horizontally, the vertical component of the velocity is 0. So it's going to be 0 you will work with. Thus, to calculate the height, you are going to use h is equals to 1 over 2 gt squared. And that's the formula you use to calculate heights of the cliff or heights from which it was launched with. Then to calculate the range, you just use this formula, r equals velocity times time. And then sometimes you can use this formulas in conjunction to find an unknown term, which will help you arrive at your final answer. When we take questions, you understand it fully. There is also a third case. A third case where, okay, what if the object was not launched horizontally from a height? What if the object was launched like this? In such a case, you just have to apply your knowledge of both an object launched at an angle, right? At an angle theta, and then your knowledge of an object launched from a cliff. So it's two in one. It's a two-in-one case, and you are not going to be asked questions from this kind of case in JAMB. This is advanced level stuff. But if it comes to that, all you have to do is break the components of your motion into the first case and the second case, which we talked about, and you should be good.